Alright, so continuing from where we left, we were done till question number 4. We'll start with question number 5 now. Okay, so the diagram shows the graphs of three functions f1, f2 and f3. The function f1 is a probability density function. Alright, state the value of k. So the most important feature of a probability density function is that the area under the entire curve equals to 1, right? And if we look at this shape, that is a triangle, the base is 2, so we need to find the height, that is the value of k. So the area is 1, we need to find the height, so half k into base, that is 2, equals to 1, that is the area. So your value of k is 1, or we have to state the value of k, so the value of k equals to 1. Then for each of the functions f2 and f3, state why it cannot be the probability density function. So the reason why f2 cannot be the probability density function is because the area is greater than 1. So yeah, if you look at this area, if you look at this curve, so yeah, the area under the curve is going to be greater than 1, and to be a probability density function, the function needs to have area, the area under the curve needs to be equals to 1, right? So that's why f2 cannot be a probability density function. f3, so f3 के साथ मसला ये है कि the values are negative, right? If you look at the curve, the values are negative between -1 and 1, right? And the probability density function gives probabilities. So yeah, if you integrate the probability density function, you will find a probability from one limit to another limit, and the values cannot be negative since these are probabilities. So the reason why f3 is not a probability density function is because negative values. So that's why f3 is not a probability density function. f2 is not a probability density function because the area is greater than 1. f3 is not a probability density function because the values are negative. To be a probability density function, the area under the curve needs to be equals to 1 and the values need to be positive. Say, moving on, gx equals to 6 in the bracket a squared minus x squared. The range is minus a to a. Show that a equals to 1 upon 2. So we know that the area under the curve is 1, so 6, integrating it from minus a to a squared minus x squared dx, and the area is 1. So when you integrate it, ये हो जाएगा a square x, ये हो जाएगा x cube upon 3 from minus a to a equals to 1 upon 6. सही है, start plugging in values, तो ये हो जाएगा a cube minus a cube upon minus a cube minus a cube and plus a cube over 3 equals to 1 upon 6. सही है, when you expand the bracket and solve this, ये आ जाता है 4a cube upon 3 equals to 1 upon 6. So a cube equals to 1 upon 8 and a equals to 1 upon 2. So yeah, so all you had to do was integrate the function from between both limits, set it equals to 1, and you find the value of a. State the value of ex, that is the mean value. So yeah, so my range is minus 1 upon 2 to 1 upon 2. सही है, so it's very simple. यहाँ पे mean हो ही क्या सकते हैं, यहाँ पे mean 1 होगा because that's the middle value. सही है, so your mean is 0. If you want to solve this entire thing, you can solve this entire thing and you'll get the same answer, but for 1 mark, and because the question says you just have to state, so simply just state that expected value or the mean equals to 1. Variance के लिए you x squared gx from minus a to a minus square of the expected value. So yeah, I'll solve this over here. Okay, so 6 bracket x squared 1 upon 4 minus x squared dx from minus 1 upon 2 to 1 upon 2. ये बन जाएगा 6x squared over 4 minus x to power 4 dx, and this will become 6 x cube upon 12 minus x to power 5 upon 5 from minus 1 upon 2 to 1 upon 2. Say, and once you solve this entire integral, your answer will be 0.05, and that's your variance. Mean हमारा 0 है, तो minus 0 squared is again 0.05, so this is your variance for the function gx. Say, the next question is the masses of cartons of sugar and cartons of flour have distributions n. Sugar follows a normal distribution with mu 78.8 and variance 12.6 squared, and flour follows a normal distribution with mu 62 and variance 10 squared. The standard load for a certain crane is 8 cartons of sugar and 3 cartons of flour. The maximum load that can be carried safely is 900 kg. Stating a necessary assumption, find the percentage of standard loads that will exceed the maximum safe load. So basically you have to find the probability that the total weight exceeds 900, right? And the weights consist of 8 cartons of sugar and 3 cartons of flour. सही है? So what we need to understand here is कि हम सीधा 8s plus 3c नहीं करेंगे. We'll take except t will be equals to s1 plus s2 plus s3 plus all the way to s8. Then floor 1, 2 and 3. सही है? So the mu for t will be 8 times the mu for s plus 3 times the mu of flour. So this will be 8 times 78.8 say plus 3 times 62, which turns out to be 816.8.4, and your variance will be 8 times the variance of s plus 3 times the variance of 8 times the variance of s and 3 times the variance of f. सही है? So 8 times the variance of s, that is 12.6 squared, plus 3 times the variance of f, that is 10 squared, So your variance is 1570.08. So yeah, so the necessary assumption that we are making here is T will also follow a normal distribution, and the T will follow normal distribution. So yeah, and the mu is going to be 816.4, and variance is going to be 1570.08. So yeah, and we had to find probability of T greater than 900. Further, it's exactly the same stuff that we've been doing with normal distribution. Z greater than 900 minus 816.4 upon 1570.08. So yeah, that is probability of Z greater than 2.11. Use a calculator, or you use the Z table to find the probability. The probability is going to turn out to be 0.0174. So yeah, that's the first part of question number 6. The second part is find the probability that a randomly chosen carton of sugar has a smaller mass than a randomly chosen carton of flour. So yeah, so that means that the mass of flour needs to be greater than the mass of the carton of sugar. So yeah, so I'll name this X and F minus S. So mu will be 62 minus 78.8, that is minus 16.8. The variance will be 10 squared plus 12.6 squared. So yes, so your variance is 258.76. Then the same stuff, X follows a normal distribution. यहाँ पे the mean will be minus 16.8 and the variance will be 258.76. Say yeah, and you're finding the probability of X greater than 0. Why? Because the mass of the mass of the carton of flour needs to be greater than the mass of the carton of sugar. So yeah, so F minus S, the mass of F minus the mass of flour minus the mass of sugar needs to be positive. So yeah, the difference needs to be positive. So X greater than 0 की probability निकालनी है. So the Z value will be 16.0 minus 16.8 upon root of 258.76. say sorry, this would be equals to, just a second, yoga greater than equals to probability of Z greater than 1.044. उसके बाद just find the value, the probability at Z greater than 1.044, the probability will turn out to be 0.148. So yeah, so this was the second part of question number 6. We had to find X greater than 0, that is the difference between F minus S needs to be positive. So yeah, and we found the new mean, we found the new variance, and then we just use normal distribution to find our probability. So the last question of this paper, the number of planes arriving at an airport every hour during daytime is modeled by a random variable x with distribution Poisson with lambda 5.2. So we know that the lambda is 5.2 and x follows a Poisson distribution. The first part is state two assumptions required for the Poisson model to be valid in this context. So the assumptions that you can write over here are that planes arrive randomly. The planes arrive at a constant rate. The planes arrive independently. These are the basic assumptions that are required for a Poisson distribution. And you just have to speak about those assumptions in the context of planes arriving at an airport. So this was part 1. Part 2 is find the probability that the number of planes arriving in a 15-minute period is greater than 1 and less than 4. So पहले तो we'll have to adjust the lambda. So x follows a Poisson. 5.2 is a lambda for 60 minutes, say for an hour. So for 15 minutes the lambda is going to be 1.3. And then you have to find the value greater than 1 and less than 4. So that is probability of 2 plus the probability of 3. तो ये हो जाता है e to power minus 1.3 1.3 squared upon 2 factorial plus 1.3 cube upon 3 factorial. So your answer for this one is 0.33. The next part is find the probability that 3 planes will arrive in a 40-minute more than 3 planes will arrive in a 40-minute period. तो पहले तो I'll do this part over here. So पहले तो we'll adjust the lambda. So y follows a Poisson. And now we are looking at 40-minute period. So the lambda will turn out to be 52 upon 15. And we have to find the probability of more than 3. So this means 1 minus probability of y less than equals to 3. So 1 minus e to power minus 52 upon 15 is probability of 0 plus probability of 1 plus probability of 2 and the probability of 3. So your answer for this part turns out to be 0.456. So you had to adjust the lambda to a 40-minute to 40 minutes. Then you had to find the probability of y greater than 3. That is 1 minus probability of y less than equals to 3. And then you just have to apply the formula and you will get your answer. So the last part of this paper is that the airport has enough staff to deal with a maximum of 60 planes landing during a 10-hour day. Use a suitable approximation to find the probability that on a randomly chosen 10-hour day the staff will be able to deal with the planes that land. So first we are now looking at an entire day and it is a 10-hour day. So first we'll adjust the lambda. So lambda will now be according to 10 hour. 1 hour के लिए the lambda was 5.2. So for a 10-hour day the lambda will be 52. Then it says we have to find the probability that the staff will be able to deal with all the planes that land. So the staff can deal with a maximum of 60 planes. So what we are looking over here is probability of x less than equals to 60. So yeah, at most 60 planes land, and that is the probability that the people, that the staff will be able to deal with all the planes that land. So yeah, but then we have to approximate it to a normal distribution. Why? Because lambda is greater than 15. Say yeah, using central limit theorem that the lambda is greater than 15, we'll approximate it to a normal distribution. So when you approximate it to a normal distribution, x will follow a normal. The mean of a Poisson is its lambda. The variance of a Poisson is its lambda. Say, and we are looking for probability of x less than equals to 60. Say, so whenever you go from a discrete distribution to a continuous distribution, you do continuity correction, right? A Poisson is a discrete distribution, a normal is a continuous distribution. So you do continuity correction. This probability of x less than equals to 60 can also be written as probability of x less than 61. So after continuity correction, you'll find the value of probability of x less than equals or less than 60.5. सही standardization के बाद z less than equals to 60.5 minus 52 upon root of 52. सही this turns out to be z less than 1.179. Using the z table, or if you through a calculator, you find the probability that turns out to be 0.881. So that is your answer for the last part. The only thing we had to do was adjust them lambda to a 10-hour day. Then you had to approximate it to a normal distribution. The mean of the mean and variance of the Poisson are lambdas, so 52 and 52. Then probability of x less than equals to 60 can also be written as probability of x less than 61. So after continuity correction, you will find probability of x less than equals to or less than 60.5. Standardization के बाद you get the z value as 1.179, and you find the corresponding value of area, and that is your answer. So that's it for this paper. Thank you so much, guys.